this computer. Okay, guys, good morning again. So I love your introduction, and you're all coming from different backgrounds, very data warehousing, development background, Tableau, sysadmins. Oh, love it. So let me give you a brief introduction about me and myself and what to expect in this course, and then we'll jump into it. I'll not take much time anyway. So it's not about me at all. It's all about you. So my name is Venkat Hari. I live in Michigan, Metro Detroit area, and most of you know me. Some of you have about 4 or 5 people I come to know only through this program, but most of you know. I'm husband, father of 2 boys. I've been in the IT for 20 plus years, various roles. And I came from development background myself too, development and architecture. So architecture is my passion. And before that, I have an extreme passion to share everything that I know, whether it's Java, whether it's AWS, whether it's cloud computing, or in general, maths, SAT for kids, or JavaScript for kids. My whole life teaching has been my passion. I believe that's what that's the reason for my living. Okay, I strongly believe in that, and this is one thing I can absolutely do it for free without any regrets. So yes, so I love teaching that much. I just wanted to emphasize how much I love it. So yes, I find happiness in giving, sharing the knowledge, sharing, helping people. That's about me briefly, okay? And it's not about me. This course is all about you guys. So yes, I've been training IT professionals, and I know some of you guys through my Java area, and Chauvin is one of them. So training IT professionals toward cloud and beyond. Yes, that's been my passion lately. So that's why you guys are here. I don't want to bore you with my details. Okay, that's about me. That's enough. Okay. So let's talk about what's this course about. So what do we do here within this 4 or 5 weeks? Okay, it takes about 5 weeks. What do we do, and what do we achieve? Okay. So I have 3 objectives for all of you guys. Okay. One is, thanks to this AWS, I want to introduce as many AWS services / cloud services as possible to you guys. It's not possible to introduce all the services that AWS offers. AWS offers about 2,800 services. It's not possible. But whatever you need, whatever the main important services that you need to be able to work as a developer and as an architect. Okay, my main goal here is kind of an architect. And I want to make you guys a cloud architect, not only with the AWS services. So by no means what we are talking in this 4 or 5 weeks is specific to AWS. Okay, these namings are AWS namings. I agree with you, nomenclature. We talk about AWS services, but all these concepts are, cloud provider agnostic. The same concepts exist with Google Cloud Platform. Same concepts exist with Microsoft Azure. So all the cloud providers, we have the same concepts. So what you are learning here is about the complete cloud concepts. But it's not just the cloud concepts. You'll be learning about networking. You will be learning about database. You already know what database is from probably a developer perspective, but you may not have seen the viewpoint of a DBA. So you will be seeing that from an architect perspective. You may not have seen a virtual machine. So you may not have created a virtual machine by yourself, but you may have logged in and played with it. But you'll be looking at from an architect perspective. So from 10,000 foot view, and even at the inch level, you will get down and do it actively. So we swing between 10,000 foot and inch level. I'm pretty good at that. So we'll do that. and understand the landscape of cloud architecture. So understand as many services as possible, and then how they fit in the bigger picture. That's the objective. And then the third objective is, I want all of you to pass the AWS Solutions Architect Associate certification. So I have a clear roadmap for you. So today we started the course. When is this going to end, and on what day are we planning on taking this certification? I have a clear path for you guys. But this is not just for the certification though. Okay, end of this 5-week training, you will be cloud architects. You'll think like an architect, you'll think like a cloud architect, and then it helps you pass this exam also. Make sense? So you will understand all the major AWS services and concepts. Yep. So, and be relevant in this fast-paced tech industry. You guys know that, how important it is. I don't need to sell you on anything. So you know the importance of cloud computing and where the industry is going. So I can safely skip this slide. Who is this for? You're already here. It's for everyone in IT, developers, technical leads, DevOps engineers, solutions architects, managers, leadership roles, anyone. Yeah. So one question that I get asked typically is, so do I need any prior coding knowledge? I have never coded. Absolutely fine. So you don't need to code. In fact, we do not code so much, but we play with it here and there. Basic Linux commands probably are recommended, but if not, no big deal. I'll teach you guys, so don't worry about it. So I do not expect any prior knowledge. I will cover everything that you need. Yep, that's what I mentioned here. So any prerequisites? Nope. All you bring to the table is just bring that can-do attitude. Yes, we can. So I'm all about energy. So bring that energy here and we'll crush it. Anything. Make sense? So let me step back and then let's talk about what exactly is cloud computing. So simply put, anything that's not running on your computer. So let's say you have you have a database running on your machine, okay, in your own data center. You're all working for big IT firms, okay, and insurance companies and all. So you have your own data center and you have your own, so all the servers exist within the data center. So if something is not running on your, in your own data center, if you are renting someone else's computing, whether it's computing, storage, any of these services, and that's cloud computing. So you will not be running in your own data center or on your own computer, but you are actually kind of renting someone else's, and you pay based on whatever you have used. So if you have used that computer for 9 hours, you'll be paying only for 9 hours. You will not be paying, so there's no upfront cost because that's not yours. You're just renting it for a few hours to run your application. So Gmail is the best example, at least in my mind. That's how I look at it. So you're not running mail servers here. So you are utilizing it. So Gmail is a classic example of one of the types of cloud computing called software as a service. We'll talk about it. Now, there are 3 types of cloud computing. Every single time we talk about cloud computing, we talk about these 3 things. I'll mention it. So anything that's not running on your own computer in your own data center. So if you're leasing someone else's computer running on that, essentially, there are a lot of complicated terminologies, but this is the simplest way that I wanted to put it. Yeah? So advantages of cloud. Yes, this is important. So cost. you do not have any upfront costs. So you will be paying for the number of hours that you are using it for. You will later on understand that certain services of AWS, they charge you per second billing. They'll give you per second billing. And in fact, sub-second billing also. Later on, we will be learning about function as a service, AWS service called Lambda. They will actually charge you in a sub-second billing. So if your Lambda is running for 5.6 seconds, you'll be paying only for 5.6 seconds. You'll not be paying anything more than that. So cost is definitely the biggest advantage. I'm not sure how many of you guys know, but Netflix started on AWS. It was completely running on AWS infrastructure. And you guys know about this, the Dropbox application. Dropbox is a cloud-based storage, like your Google Drive, right? So Dropbox was completely built on AWS. So that guy, Dropbox inventor, CEO, so he was going to college and then taking all these files in USB drives and all. He was so frustrated. So he built an application behind. AWS has a service called S3, Simple Storage Service. He built a GUI on top of it and made it, he popularized it. And it's a several $billion company now. Of course, 2 years back, they moved completely off of AWS to build they built their own infrastructure now, but they were on AWS until 2 years back. Same thing with Uber, Lyft, whether it's AWS or Microsoft Azure or Google Cloud platforms. One of the cloud providers, they did not spend $1 on the upfront costs because they don't know, all these startup companies, they don't know if their idea would fly or not. It may or may not work. So they don't want to build a data center with several $1 million with upfront costs. They don't have that much money. It's just a startup company. They have a fantastic idea. Don't know. Who knows if the idea is going to work or not. So you, with cloud, the beauty is that you don't have that aspect. So you can walk into cloud with the complete idea without having $1 in your hand. That's the beauty. Pay as you go. Okay. So another biggest advantage of cloud is infrastructure as code. You guys are all you're all working in various organizations. You guys know for the last decade and a half, when you need a database server, you will have to raise a request to your database team, and they'll go to the infrastructure team. They'll go to they'll go to the vendor and ask for servers. So once they get the servers, the physical servers, then they'll install the database. You guys know how long it typically takes. It used to take months. Months we have, after virtualization came in, we cut down to weeks and days. Okay. But with the cloud, pretty much you can write your code, you can build your complete infrastructure of your company by running a simple script. Trust me, it can be done in 30 minutes, meaning the whole setup. It includes all of your servers, including your load balancers, all the compute services, all the storage services, all of this together. Your complete landscape can be built in probably 1 hour. You just write the script, take your time, and write the script, and you can run the script. It's code. So you are treating infrastructure as code. So it's no different anymore. Because the beauty is, either it's AWS or other cloud providers, they're exposing them as APIs. I need 5 virtual machines. Sure, you can make an API call and get it. That's the beauty. Yeah. And elasticity. You're all cloud architects. You need to understand this term elasticity. Very upfront. So elasticity essentially means it's expanding and shrinking. The nature of expanding and shrinking. So I might, my business might be okay today with five machines, but on Black Friday, the same company, I might need 1,000 servers. Okay, day after Black Friday, I can come back to, I can live with 10 servers. And the day after that, probably I can safely come back to 5 servers, my original servers. So the nature of our usage patterns is different. So you can grow exponentially, you can shrink exponentially also. That is called elasticity. So that's the beauty of cloud computing. So you can keep adding the resources dynamically because it's all code and it's a piece of cake. We will talk about, there is a concept called auto scaling group. Okay. So you can scale automatically. So let's say you found out from your load test patterns that my server can handle, each server can handle 40 concurrent requests. So you can configure your AWS services, your auto scaling group in such a way that once it crosses 40 concurrent requests per second, spin a new instance, spin a new server. Okay, and it can keep growing. On your Black Friday, servers get added automatically. Or of course, you can scale manually also. So elasticity is one of the biggest benefits of it. You can grow exponentially and then shrink in the same fashion. And it's so cheap to do it. And it's so easy to do it with cloud computing. Because you are renting someone else's machines, right? And you're only paying for those many hours that you are using it. And the entire infrastructure is exposed as beautiful REST APIs, so you can call them. You can write a piece of code to build the infrastructure. It's that beautiful. Well, yes, productivity. So no more in your own data centers, no more racking and stacking. You don't have to worry about it. You'll be productive. You can have your complete infrastructure up and running in minutes. And of course, performance, yes, because the reason it's cloud computing, especially these cloud providers are so performant is because they know they are best at what they're doing. So they will continuously find out the performance bottlenecks within their hardware, and then they continuously replace it with the brand new hardware. They will do that. And we don't have to worry about it. And we are not that good anyway. And speaking of cost, I'll go back to the first point for one quick second here. The economies of scale here. When we talk about cost, right? AWS or Microsoft Azure, these guys goes and buys hundreds of thousands of computers, hundreds of thousands of CPUs. Okay, terabytes of RAMs. So when they buy, companies like chip manufacturers, when they buy, they will bargain the price. So the economies of scale, we can never beat them in the cost. So security, you may be thinking, why is security here? I always felt that cloud computing is not so secure. Not exactly. Yeah, there are a couple of instances where iCloud photos have been hacked and Google Drive may have been hacked and all. But if you really look at it, the security, all these cloud providers, especially the top 3-4 companies, right? They have a multi-layered security, pretty much. They have at the physical level security. They have virtual machine level security. They have of course, you take care of the application level security. But other than that, they have a multi-layer of security, and they have been doing this. They have been in this business for decades, and they can do much, much, much better than any of us, including the physical, of course, physical security. They have it pretty much. Who has access to go into that particular room, the server room? Within the server room, who has access to these particular physical machines? So they have a highest level of security. So security is also one of the advantages of cloud. I want you to understand that. Okay. Of course, reliability. We'll talk about why it's so reliable if we can architect it properly. Okay. And they have, if you need one server, you can actually have this particular server, redundant copy of this particular server in a different data center. In case something happens in this particular data center, then you'll be able to recover quickly. In fact, your availability will not be impacted. So these are all the advantages of cloud. Before I talk about types of cloud, anybody has any comments, questions, anything? Let me take a few seconds break here. No comments? What do you guys think? Do you guys agree that security is one of the advantages, or cost, as a matter of fact? Cost is an interesting aspect. You have to architect right to get the cost benefits. So you can be on AWS or any other cloud provider, and it can be pretty expensive if you do not architect it right. So you will have to bring all those good architecture principles and put that into practice to get the cost benefits. I want you to understand that. We will look at it pretty deeply. Any questions, comments? Does it make sense?
Yeah, sure, absolutely.
Yes, makes sense. Thanks.
Yep.
Yes.
So let's talk about the types of cloud. Being a cloud architect, you must be familiar with these three types of cloud. There are three kinds of cloud computing at the highest level. So one is called infrastructure as a service. In the infrastructure as a service, you talk about the lowest level of cloud computing. So this is where you'll talk about physical machines, virtual machines, your storage, RAM, okay? And this is where we will be spending most of our time. So AWS is one of the cloud providers. So AWS has been in this infrastructure as a service. Well, most of these cloud providers are, other areas also, but AWS and even Google Cloud Platform, Microsoft Azure, these guys play predominant role in this infrastructure as a service. So here, essentially what it means is you can rent someone else's computer, you can do whatever you want to do it. And after that, you are responsible for it. They will give you a machine with the operating system installed on it. And after that, what software you want to install, how do you want to protect it, who can access to that, all of that is your responsibility. It's your code. All he's doing is you are renting someone else's computer. You are pretty much renting the computing resources, computing service, and then operating system is installed and you can go from there. That is infrastructure service. There's one more level, one more layer on top of infrastructure service called platform as a service. So here, what they will do is, rather than providing pure computer with the operating system. They will provide the computer operating system. Along with that, they will provide some runtime environment. Let's say Java-based applications. They will install JVM and expect you to write your piece of code in certain way. And then they'll say that, hey, I have the Tomcat installed here. Tomcat is one of the web servers for Java to deploy Java-based applications, right? So I will bring Tomcat applications also. All you do is bring your deployable artifact and put it here, and everything is taken care. But you have to write code in certain way, meaning since I'm bringing this Tomcat server, so you cannot deploy a C# based application. So here it's little more restricted because your runtime environment is built into it. So this is where there's some examples out there called Google App Engine. So Google App Engine will provide different runtime environments, one for Java, one for Python, one for Go, and other programming languages. So you code according to what they say, according to their specification, you code it and deploy it in their platforms. Let's call this as a platform. Deploy it in their platform. And the beauty is with platform as a service is that you don't have to worry about the underlying infrastructure anymore. You don't worry what operating system it's running on. You don't have to worry, how much RAM do I have to allocate? You don't have to worry about it. It will grow. The platform as a service, it will automatically grow, and you don't have to worry. They will take care of it. So you bring your code according to the specification of the platform, like Google App Engine dictates that, for all the Java developers, I expect you to build a servlet in the front. Okay. So it's a servlet-based web applications. So bring your deployable artifact, they call it a WAR file, web archive file. Bring that WAR file and deploy it in me, and they have their own platform. They use a server called Jetty. It's like Tomcat. It's a Java-based another web server. So you just deploy your deployable artifact there. And similarly, AWS Lambda, they expect you to code certain way, and they will say that you don't worry about the underlying infrastructure. It's a little more abstract. Yeah. And now the third layer is, this is even more abstract. This one is called software as a service. In the case of software as a service, you not only have to worry about what machine it's running on, what operating system it's running on, you don't have to worry about what programming language it is on, what platform it's running on. You don't have to worry about any of that. The beauty, the best example here is Salesforce.com. So Salesforce.com is the best example for software as a service. So essentially you have a small business and you want to get some leads for your business. Yeah, you can go to Salesforce.com and create your own account. You don't have to worry about underlying infrastructure. You don't have to worry about whether it's written in Java or C# or Python. You don't have to worry about any of that. You get your own account and they'll take care of everything. Like your Gmail account. We all have Gmail accounts. We don't worry about what infrastructure it's running on. We don't worry about whether it's running in Angular or React or some other front end. You don't have to worry about any of that. You just have your account, you just log in. So use it as a complete service. Your software itself as a service. Your Google Docs. Make sense? So it's very important for all the cloud architects to understand it, because the cloud providers, especially being an architect, you may have to choose the appropriate type of cloud. In some cases, if you don't have to worry about deployment on platform, code, any of that. Maybe software as a service is the best example. Salesforce.com. How about the platform as a service? So you have some applications, but here, when you talk about the platform as a service, you don't have a whole lot of flexibility in what programming language you're going to code. Let's say you have written your piece of code in Clojure. Okay, they may not provide runtime environment for Clojure. Okay, also, let's say you have an old legacy Java-based application that may not be portable into platform as a service. In that case, unfortunately, what's the only option that you have? Infrastructure as a service. So in the infrastructure as a service, pretty much you got your physical machine, not physical machine, but virtual machine. We'll talk about it in a minute. What's the difference between physical machine and virtual machine? So you get your machine with the operating system installed on it, and you can go bonkers with it. You can do whatever you want to do it, or you can do whatever you need to do it. Okay, most flexible. If you are, let's say, you have a legacy Java-based application servers, IBM WebSphere or something like that, yeah? Then go take it to your infrastructure as a service, because platform as a service, unfortunately, does not work, because they only support so many containers. They probably support Tomcat and Jetty-like containers, but they may not support others. So in that case, the most flexible one here is obviously infrastructure as a service. Pretty much you are renting someone else's machine and you can do anything. You can install anything on it. Does it make sense? But if you are coding from scratch, brand new in 2020, maybe now you have choice. Do you want to go to the infrastructure level? Maybe, or maybe not. Depends on the use case. So you can try with the platform. You can write a piece of code according to the platform. Let's say AWS Lambda, go deploy your piece of code there according to the specification. And then pretty much you don't have to worry about the underlying infrastructure. That's the beauty. We will be playing with AWS Lambda and serverless technology. We will be building a simple concept with the AWS Lambda and API Gateway. So that's about it, guys. Does it make sense? You're all cloud architects, so you need to understand these concepts at the core, so that you'll be able to architect them well. Any questions? I can take some questions here.
Yeah, I got a question. Okay, go ahead.
Absolutely, go ahead.
Farhad, go ahead.
So who decide which option you're going to? Like let's say you have a company, and who decide? Not a small company. Let's say you have an enterprise level company. Who decide?
So it depends on your company culture, though. But most of the times, it's you will play crucial role. Architects play a bigger role. Most of the times, architects are the ones that influence the decision. Your enterprise architects or solution architects. Because now, let's say, I'll take a classic example, right? So let's say you have I will take this example. Let's say you have AS400 running for the last 3-4 decades. Unfortunately, if you have AS400 running, you can't even migrate to cloud without changing your application architecture. That's one thing. Understand that. If you have a mainframe running, okay, I want to go to cloud, then you have to completely rip your code apart before going to cloud. There's no other way. So you can't go to cloud as is, period. Now, let's go talk about the next level. Let's say you have a old school IBM WebSphere that's been sitting out there for the last 15 years. You have some licensing and you do not want to change the code, but you want to take advantage of the cloud computing. like elasticity, cost, all of this, performance, right? So you want to take advantage of it. So what do? Obviously, you cannot take a platform as a service. You must take as an infrastructure as a service. It's a brand new, because you want the most flexibility there, because you already have licenses with IBM WebSphere, and IBM WebSphere cannot be supported. It's not supported as a platform as a service anyway. So what you do is you take infrastructure as a service. That's the only option you have it. You're renting a virtual machine there, and you go install your IBM WebSphere on it, apply your licenses, go take your code, and then deploy it. Does it make sense? If you're doing, so that's about the infrastructure service, right? Let's say you guys decided to, you have got a brand new project, and then you wanted to code from scratch, and then you wanted to deploy it brand new in 2020. Now you have an option. Okay, what kind of application architecture is it on? Do I need to worry about the lowest infrastructure as a service? Or can I go do it in AWS Lambda, if in the AWS world, or Google App Engine? See, I'm losing some flexibility there, because I have to write my code according to the spec, right? So that I will be able to deploy it in the platform, and now I don't have to worry about the infrastructure. So I'm losing some flexibility for good. I'm losing some flexibility, and I'm coding according to the specs, but I will not have to maintain the infrastructure. Everything is handled by AWS or Google. Does that make sense? So who manages that?
Yes.
Who makes the call? Most of the times it's enterprise architects, and you guys play. You cloud architects, being a cloud architect, you will influence it.
Sure, thank you.
Yep, Sean.
Yes. See, for PaaS, you mentioned that there are some, we have to really, the code must comply to the specification. Now, I would like to hear a little bit about that specification or examples of specification.
Yep, specification, when I say specification, so platform as a service, let's talk about Google App Engine. So Google App Engine says that, as an example, they will say that I will bring Jetty as a servlet container. So Jetty is a web server where you can install your Java-based applications. So Google App Engine is built on Jetty server. So now you ask yourself, Jetty, what does it support? Okay, it supports only Java-based web archive files. But if you have some concepts like EJB, and if you want to build it as a big enterprise archive file or something like that, obviously it doesn't support that. So that's where you lose the flexibility. Make sense? That's with the Google App Engine. Now with the AWS Lambda, again, Google App Engine not only support Java, guys, Java, C#, Python, Ruby, Go, it supports it. AWS Lambda supports a lot of the platforms too. It supports Node.js, Java, Python, Go, C#, all of these platforms. With all the platforms, so Lambda is a slightly different. We'll talk about that later. So essentially, it's a event-driven architecture. So when event raises, you can call the Lambda function there. Okay, but you have to write according to the spec, meaning they will provide some interfaces. You will have to implement them. That's all I mean. So some AWS code will be there within your code base, buddy. That's all I'm saying. Does that make sense? With the both examples, one is they bring Jetty into the picture. So whatever Jetty can support, meaning a simple web archive file only can be deployed. It doesn't have support for big EJBs and all. That's what I mean in the pure Java world when I talk about. Okay. And similarly, let's say you are coding in a programming language that does not support that is not supported by Google App Engine yet. So what do you do in that case? This is probably, let's stick with this example so that everyone can understand. So you happen to have coded in a programming language that is not supported by AWS Lambda yet. What do? What are your options now? Your only option is infrastructure as a service. Does that make sense?
Yeah, that makes sense.
So that's what I mean by spec. So you'll have to, you lose some flexibility because they only support so many programming languages. And even those programming languages, they may have some restrictions. Within Java, they'll say that they do not support EJB containers and all. Yeah, who needs that if you're coding in 2020? Even back in 2015, you don't need EJB containers and all. Does it make sense? But if you happen to have one right now as a legacy, then go with infrastructure as a service and then install anything you like, because you got your machine. You can do anything. Is it absolutely clear, Sean?
Hey, Venkat, this is,
Clear, sorry.
I have one quick question.
Yep. Manohar?
Yeah, this is Manohar. Yep.
Go ahead.
So as of now, we discussed about the advantages, right? What are the downsides?
Good point. We'll talk about that. I'll get to that actually. That's a good point also. So if you do, actually, maybe I can go back. I can talk about it right now. So let's talk about the same advantages itself. Let's understand a bit. Okay. I know a lot of companies who have got their hands burnt due to cost in cloud. That's pretty interesting, right? I said cost is #1 advantage of cloud, and I said a lot of companies have got burnt. It's not the tool. It's not the knife. It's about how you use that knife. So if you do not architect well, it could be very pricey. So if you're not taking advantage of, all the architecture principles, okay, then it could be very pricey. Let's say that I'll give you one classic example, Manohar. Let's say you need 50 servers in production. So for all of your testing scenarios, you wanted to have a pre-prod environment. So in prod, you need 50 servers, and in pre-prod, you need 50 servers. Okay. I mean, you wanted to duplicate the environment so that you can exactly simulate it. So, but you only need these 50 servers, exact replica of production. You only need it once a month during your load test. Does it make sense to have these machines running the remaining 29 days? If you have architected it that way, okay, you have your pre-prod environment to be exact replica of production, both of them running 50 servers each all the time. As an architect, you did not do a good job there. Because you know the requirement here, you only need this exact replica of production once a month when you do the load test. Take advantage of your auto scaling. Okay, scale it down from 50 servers to 5 servers and live with the 5 servers. And when you need the load test, you can expand it. The elasticity is one of the beauty of it, right? So elasticity. So expand it to 50 servers minutes before the load testing, run your load test, and then terminate the instances. If you did not architect it, I know cost has been a problem for a lot of people who have architected it poorly without understanding the ramifications. That's one. Okay. The next one is your compliance reasons. There are good reasons why you don't want to go to cloud for compliance reasons. So, especially in healthcare industry, they have probably the strictest rules in the United States, at least. I don't know about other countries, but at least in the United States, healthcare industry has got the strictest rules. So they have a lot of compliance reasons. One of the compliance rules says that probably your code cannot be running with other clients' code. So you cannot deploy your piece of code in a multi-tenant environment. In cloud, keep this in mind, guys. From here onwards, being a cloud architects, understand the term multi-tenant. So let's say you have an apartment complex, and within an apartment complex, you have given it for rent, and each one of them is a tenant, right? So similarly, here, the physical infrastructure has been built by this AWS or Google or Microsoft Azure. They built it, and then there, I'm deploying my piece of code. I'm taking a piece of hardware, and you are taking another piece of hardware. They happen to be sitting in the same physical machine. If you have a compliance reasons that say that, sorry, your code cannot be in a multi-tenant environment, then you'll not be able to go to cloud. That can be definitely viewed as a disadvantage. And security can be a disadvantage if you do not architect it well. Because here, when you go to the cloud, we will have to understand the roles here clearly. What is your responsibility versus what is AWS responsibility? AWS worries about the physical security of it, and the physical machine security, the building security. Okay, setting up the 24/7 surveillance cameras. Okay, all of that, they will take care of that. And beyond that, once you take their machine, once you rent their machine, it's application security. They don't do anything about it. That's your responsibility. So the responsibility segregation has to be understood clearly. Then you'll be able to architect it better. Otherwise, it can be a problem. Better go with your private cloud, meaning your on-prem, pretty much. Does that make sense? Compliance reasons and legacy. Legacy is another one. So let's say you have AS400 systems or mainframe systems running in your company. Unfortunately, they can't be moved to cloud because they are not supported. So you'll have to architect them well. You have to understand it's a different landscape. Understand the security ramifications, understand the cost ramifications. Take advantage of all the nature of elasticity and infrastructure as a code, and then try to automate as much as possible. Make sense, Manohar?
Yes, sir.
Excellent. So with that said, so being cloud architects, you need to understand to the core what these three things are. And then let's talk about these deployment models. There are three kinds of cloud deployment models, okay? So one of them is public cloud. So what exactly is a deployment model? Well, what kind of, so how do you deploy how do you provision your new instances or new virtual machines, okay? So what's your idea behind that? So one is public cloud. So in the public cloud area, essentially what you're doing is, so you're completely relying on some other cloud provider like AWS, Google, and Microsoft Azure, and we have IBM, Oracle, and Alibaba. So all of these are public cloud providers. Pretty much, you don't bring a dime and no contracts. You can definitely sign some contracts to get a better deal. We will talk about that later. So ad hoc instances versus reserved instances, we'll talk about all of that. But essentially in the public cloud environment, you do not have any kind of hardware running in your own data center. Everything is in public. I have worked in companies where we have complete public cloud. We did not have a single machine for the whole company. It's a publicly traded company. We provided APIs to a lot of automakers, automobile companies, and we were able to serve millions of transactions per hour for each automobile manufacturer. We did not have a single machine in the data center. In fact, we did not have a data center. It's a complete public cloud. It's entirely possible. And this is the best case scenario, okay? But you may not get there. So hybrid cloud is the most pragmatic scenario for most of the mid to large enterprises. Okay, what exactly is hybrid cloud? Well, in my current company, let's say, we already have a data center. We have all the servers deployed within our own data center. Well, so what we are planning on doing is, let's say we've got a new project. We wanted to build, part of it in the cloud. So there are some good reasons why we wanted to go to cloud, because again, like any other startup, we don't know if that idea works or not. If I'm not sure if my idea works or not, I don't want to spend a dime on it. There's no point in spending it. Rather, I will rent someone else's machine and then use the public cloud and build my new infrastructure there. But I have my old infrastructure in my private on-prem data center. So there are some strategies out there on how to bridge them. We will talk about that later. We'll talk about VPN connectivity and direct connect and a couple of options there. We'll talk about that towards end of the course. But essentially, some of your infrastructure is on-prem and some of them is in public cloud. That is called hybrid cloud. This is probably the most interesting one, or most practical one. Let me put it that way. Let's say there are a lot of insurance companies, right? They have a lot of data centers already. They have a lot of servers already here. But every new project, it's as a cloud architect, you must ask, should this be deployed here? Can I take advantage of cloud for this one? Okay, maybe I have a compliance reasons why I don't want to go to cloud. Sure, can my code be running in cloud and have the database be running in my own data center? Is that acceptable from compliance perspective? Understand here, my code computing is running in cloud, but my database, I want to take advantage of my database instances already running in my data center. So the computing that is running in cloud can take advantage of my database. So I'm not moving my databases. I'm only moving my web servers and application servers. I will leave my database servers here within my own data center. That's a hybrid cloud. And the next one is private cloud. Essentially, in private cloud, or it's also called on-prem, pretty much you have everything running in your own data center. Or in some cases, on a dedicated hardware, there are some private cloud vendors where you are not sharing the hardware with some other public cloud providers, like in public cloud providers. So you have a dedicated physical machines will be given to you, and then they will manage the data center, the cooling, power, all of that. The private cloud vendors, they will take care, but you will get your own physical machines. And dedicated, by the way. That's your private cloud, or even your on-prem. So in your private cloud area, you are still taking advantage of your cloud computing concepts. Okay, so you have your softwares like a VMware. Okay, so you install VMware on top of your bare metal, meaning your servers, and then virtualize it. You slice a single physical machine into multiple virtual machines or multiple containers. You slice it, and then you're still taking advantage of your virtualization and all of your, you'll be able to, you're taking advantage of some of the cloud concepts here, right? So that's called private cloud. Pretty much it's on-prem. So the public cloud is the biggest benefit. So that's where all these big guys come into picture. AWS, Google, Cloud Platform, Microsoft Azure, and others. Okay, with that said, let's talk about, so who are the big players in this public cloud industry? Okay, so AWS being the #1 unquestioned leader at this point. If you really look at it, see, this is a magic quadrant. Okay, you really look at this one, AWS is here. Okay, this is as of 2019. Okay, from Gartner from 2019. This is Amazon Web Services here, and it's sort of closely followed by Microsoft. Google is still trying to catch up. Microsoft is doing pretty good too in this cloud industry, public cloud industry. Okay, Google is there. Alibaba, Oracle, and IBM, they are kind of niche players. They're kind of out there. They're slowly picking up. Oracle also is picking up decent. Okay, but Amazon Web Services did not have any competitor for 7 years. Watch an interview by Jeff Bezos, Amazon CEO. He will tell you, we did not have any competitor in the cloud industry for 7 years. They're visionaries. They just led the whole industry. They have taken it to the next level. Do you guys know the story, how it happened actually? How the complete AWS has come about? So what happened, this is in somewhere mid-2000 areas, okay, or early 2000 areas. So Amazon was doing pretty well as an online shopping site. So they wanted to build infrastructure for their own site. And then they hired some consultants and then asked, okay, can you give us your opinion? And then a couple of people have taken the task, and then they wrote a white paper and then submitted to Jeff Bezos and others, saying that, hey, you need this much infrastructure to run your Amazon.com. But what you can do is, some of the infrastructure, you don't need it all the time. You can rent it. You can rent that infrastructure. Okay. This was not by no means it's a brand new concept or anything. Rackspace and all were doing really, really well right before Amazon. In fact, Rackspace competed with Amazon for quite some time. Okay. After that, they kind of gave up. That's a different story. So the point is, so they built this massive infrastructure and they started kind of renting it service by service. I will talk about what's the first service that they did. It's called Simple Queue service. And then slowly what they did, they had a massive, the storage service. So they built this simple API-based object store called Simple Storage Service, S3, that's what they call it. We will go very, very in depth on that. But essentially, they started renting it out. And that's how they built. They started with a couple of services, followed by a few more services. Every single year now, they're adding hundreds of services. Now there are more than 2,500 services. So it's impossible for me to teach or anyone else in the world to kind of even know all the services. Make sense? So they'll keep adding the services on a daily basis, weekly basis. So AWS is undoubtedly the leader in this industry. So let's talk about the certifications, AWS certifications. So this is the structure, guys. So there is the beginner, the foundational certification called AWS Certified Cloud Practitioner. I will not recommend for any of you. You guys don't need to take this one. It's mainly for the people, newbies and management leadership, senior leadership, even C-level people can easily take it to understand what it is and how they can bring the change. Yeah, it's pretty straightforward exam. This one is a relatively easier one, but in the next one we have this. They call it associate level certifications. You have a solutions architect associate, you have a SysOps administrator associate, you have a developer associate. And our focus is going to be on this AWS certified solutions architect associate. You may be thinking, some of you may be thinking, hey, I may want to go with the developer associate. I highly recommend you start with the solution architect, because solution architect will give you little bit, if not the complete depth, but all the important services that AWS provides. Then go into the depth of it. Developer needs a lot of depth on only few topics, but solutions architect, you are looking at as an architect from 10,000 foot view with the complete landscape you are looking at it. And then after this one, the most prestigious certificate out there is AWS Certified Solutions Architect Professional. This is the hardest and probably the most respected certifications out there. Okay, I highly recommend you take it only after this one. Make sense, guys? So now, with that said, let's talk about the course. What we do here, when do we meet? So we meet typically on Saturdays and Sundays from 8 to 12. And most of the times I try to avoid weekdays, but in some cases, if I can do one weekend, I will have to make that up in the weekdays. So, and that could very well be tomorrow. I'll have the total night, overnight deployment. It starts from midnight and all the way until tomorrow, 7:38. So we may have to do a weekday tomorrow. We'll see. Okay. And how do we meet? This is how we meet. Zoom. This is how I use it. And where to check for more details. As soon as the class is done, this video is getting recorded right now. It gets converted into something that I can upload to YouTube. So I will upload to YouTube. I'll start with the public YouTube. I make them public, but eventually I'll only give it to people who have come to this class. So I make them private. I will make it available only for you guys and provide the links in my website. So nextstep.training. So understand this is the only website you need to know. NEXTEP, there is no S there. And it's not .com, .training. So that's my website. That's where the video goes. All the video goes there. My homework goes there. These PowerPoints go there. Everything will be in one spot. That's my kind of a single place.
I got a question actually. See, there was a little bit of a break when you were talking about your website where you'll be posting. Could you please repeat that portion? Yeah,
absolutely. So what I'm saying is, let's go ahead and open it up. So this is my website, nextstep.training, nextep.training. This is my website, okay? And this is the only thing you need to know. So I put my previous Java training videos here and then AWS training here. So go to videos. And then if you look at it, this is how I'm planning on doing it. Batch 1 videos, batch 2, and you will see the batch 3 here. Okay. And this is like a one-pager. This is how it's going to look like. So this is an introduction and EC2, all the videos here. This is the video link, the description, what this video has. And if there are any homework link will be there. let's say EBS homework, ALB homework, ASG, each one of them is a document by itself. And these homeworks are very, very, very important ones. This is how it looks like, very detailed, and those are objective driven. So, and all of you guys will work together on these homeworks, okay? See this one, objective one, understand the concept of application load balancer, okay? How do you do that? I give you very precise steps on how to do that, okay? So this is S3, miscellaneous topics, everything. This is, we'll be covering it, okay? And you'll have some serverless concepts. You have the most important topic called virtual private cloud and Lambdas, API gateway, your relational database store, Route 53, all of it. So, make sense? And then your how to join is here, and your prerequisites is here. There are some Linux commands that we typically use it. So you can use them here. You can come to this site to look at this, to this page. So play around with this simple website, very, very, very simple website. Yeah. Okay. And these are the important dates, guys. So today is July 18th, course start date. It will go for 5 weeks, about 5 weeks. It's actually supposed to be 4 weeks, but I give that additional week in case something comes up. So August 16th will be the last day of course, okay? And then from July 18th to August 16th, we will have worked on every single topic that's required for your exam and to become a cloud architect. Every single topic. To an extent, it will not be complete. It will not be enough to take the exam on July 16th. I can tell you that, but you will be cloud architect within this, okay? You will have appreciated all the concepts of cloud and most of the services of it and play with it, yeah? So what happens, and in between from July 18th to August 16th, so within this almost 1 month time period, you guys meet a couple of times a week apart from my training. So you guys will meet and then do my homeworks. Within the class also, you'll be doing the homework, okay? So we will be spending a lot of time together here. But after this point, pretty much Venkat will not work with you anymore. I'll be the coach on the sidelines. I'll give you the high level idea. And then from August 16th, you will spend 4-week time, every single person who joined today, right? Sometime on August 16th, what we will do is we will meet together. We will pick an exam date. And I want the exam date to be a single date as closely as possible. Not every person will get on the same day. So some people may be taking exam on September 14th, and some people may be taking on 16th, and some people may be on 17th, but around that area. And all of you will be preparing for the exam together. That is the most important one. So there are a lot of Udemy courses out there. There are a lot of online courses out there. You don't need to come, join this course, right? But the beauty here is that we will be doing this together. We will be working on the homework together. We will be doing the projects together. We will be experimenting it together. We will be learning together. We will be preparing for the exam together. We will be taking the exam together. That's the power. So that's the power of mastermind. And I'm creating the mastermind here with you guys. I'm just the catalyst here. You are the reason, why it's so good, why it works. Does that make sense?
Yeah, yes, Venkat, it's good.
Any questions?
Yeah.
And trust me, it works. I've seen this working. So we will make, good friendships here. My previous batch people, they met continuously and they built a lot of network relationships here. And some of them helped each other, getting into the new jobs, honestly. So it helps. I want to be like that. So go ahead.
Venkat, can you repeat the timing? I didn't get the timing.
8 a.m. until 12 p.m. So it's about 4 hours. And don't worry, guys. I will not be talking for this long, and I will never talk for this long. I'll probably talk for an hour or so, and then I'll give you kind of a break in the homework kind of break. So what we'll do is we'll come back, and I'll use the concept of Zoom concept called, what's that called? Breakout rooms. Okay. So in the breakout rooms, what happens is there are 12 people here in the call today, right? So all the 12 people, I'll break them into probably 4 different groups. I'll break them into 4 different groups, and I'll give the homework, and then you guys will be doing it. Actually, you'll be doing that today. Okay. I have a clear objective on what needs to be done today. So with that, we will be getting into some deep concepts of AWS. We'll talk about global infrastructure briefly. We'll talk about it, what the region is, availability zone is, and then let's go right into the practical. Like we will go and provision a virtual machine in the cloud somewhere. Okay, and then I will do it first. I'm assuming all of you have signed up for free AWS free tier account already. So what we will do is, I will do it first, and I will show you, and then I will we'll break it into 4 different breakout rooms, and then you guys will do it. So every single class, we will be working here. It's not just me talking. If it's me talking, you don't need to come here. There are a lot of Udemy courses out there online. If you're that disciplined enough, you can do it. But we will be actually working here, and I'll force you to kind of do it.
Hey, Venkat, quick thing. I
Absolutely.
have a doctor appointment for my mom.
Okay.
So I'll be online from my phone.
Yep.
But I already create the account. But maybe for today I cannot join.
No worries. I'm glad you brought it up. That's Farhad, right?
Yeah.
So I'm glad you brought that up. So the beauty is you can watch the video anytime. I will post it as soon as it's done. Probably 1 hour typically. I'll take 1 hour for the conversion. After that, I'll post the video as is. I'll post the video, I'll post the slides, I'll post the homework. Everything will be online. So you can go do it in the evening time. So you will never miss any class.
Perfect. Thank you so much.
You're welcome.
Okay, I have a few questions. Yep. See, these are a couple of logistical questions. See, in case we meet in the evening, if we missed a Saturday or Sunday, then what time do we meet?
Excellent question. 6:30 p.m. EST.
6:30 p.m.
6:30 p.m. EST.
Got it. Next question
for
is
for about hour and a half or 2 hours. That's the maximum I can do on the weekday.
Okay, that's fine. Okay, next question is, how much is the exam fee?
Exam fee is $150.
$150. They give you 1 chance or 2 chances?
1 chance.
1 chance. Okay.
Mm-hmm.
The other 2 questions are technical. That is, see, I've also certified in one like Pivotal Cloud Foundry, and also I've heard about Kubernetes. Mm-hmm. So how are these clouds related to AWS, or how different?
Okay. It's 9:33, right? Okay. Yeah, I can take the questions. Both the questions actually, briefly, because I can only talk briefly. So let's talk about the first question is Pivotal Cloud Foundry, PCF. So let's talk about the types of cloud, right? We talked about infrastructure as a service, platform as a service, and software as a service. So Pivotal Cloud Foundry sits in the middle, platform as a service. So this Pivotal Cloud Foundry, what they did is, the idea behind Pivotal Cloud Foundry is, so you don't have to worry about what infrastructure it's running on, what are the physical servers, what are the virtual machines. You don't have to worry about any of that. So they have it's a very complex architecture. The PCF itself is a pretty complex architecture. They have routers, they have request processors, all of that. Okay, but essentially what their idea is, we will build something called container. Okay, so container is a lightweight kind of machine. This concept came from the Linux container days. So Linux has this concept of Linux containers. So you have this kernel and you have this Linux containers. So it came from the Linux container days. So essentially it's a lightweight container that comes with its own runtime environment. When I say runtime environment for Java, it's JVM. It comes with all of that. So you just deploy your piece of code there. Okay. So the point there is, so we have this concept of containers. Each virtual machine will talk, actually we did not talk about what, difference between physical machine and virtual machine. So we'll talk about that in a couple of minutes. So essentially, once you have a computer here, okay, you have a physical machine. One physical machine can be sliced into multiple virtual machines. Each virtual machine will have its own operating system. So in the evolution of the whole computing, if you look at it, you have your physical machines, you have your virtual machines. Converting your physical machine into virtual machines is called virtualization. So what you do is, on your physical machine, you install a thin software. It's actually firmware that talks directly to the hardware. Okay, it's called VMware HVM hypervisor. Okay, it's called hypervisor. So your hypervisor will be installed directly on your hardware. Okay, so now let's say your computer is actually 4 physical CPUs. Once you install your hypervisor, you can make your 4 CPUs, you can virtualize into 16 virtual CPUs. They call it vCPUs. So you are converting your 4 physical CPUs into 16 virtual CPUs. And each one of them, you can install something called a virtual machine. Virtual machine essentially means that you never know that that's a virtual machine. You get the feeling that it's a physical machine, but you can install any operating system. So maybe a host operating system, there may be a host operating system that, let's say that's a Linux operating system. On top of it, you have a hypervisor. Since you asked, actually, let me go jump into it, right? See this one? In a simple physical machine, you have a hardware. On top of hardware, you have an operating system. And on top of operating system, you have multiple applications. This may be a Microsoft Word, PowerPoint, a database service, or Apache web server. This is how a typical physical machine is. Now, let's talk about when we virtualize this, what happens is you have your hardware. This guy. Are you able to see this little, this guy here?
Yes, I can.
I don't want, okay, there you go, that's better. So you have your hardware, and on top of hardware, you have your host operating system. So let's say this one is Linux operating system. On top of it, you will install another piece of software called hypervisor. So there are a lot of options out there. Amazon has its own HVM, and you have your most popular one is VMware hypervisors. Okay, so what this hypervisor does is it will make this, let's say in this case, 4 core CPUs into multiple virtual CPUs. That's what it does. And once you expose your 4 physical CPUs into, let's say, 16 virtual CPUs, now you can install multiple virtual machines. You can essentially get 16 virtual machines on a single physical machine. Now you'll be able to install multiple virtual machines, and each virtual machine can have a separate operating system. This is called a guest operating system. This may be a Linux, this may be Unix, this may be Windows, this may be anything. Everyone gets the feeling that, okay, this is my machine, this is my computer. No, you're all sharing the same hardware if you really look at it. So what we are going to do now is, okay, we are going to rent a virtual machine. This is what we are going to do it. We are going to rent a virtual machine from AWS, and we will install a guest OS on top of it. It will come installed. Okay, we will be installing Amazon Linux on it. Amazon has its own flavor of Linux, and we will be installing Amazon Linux on it. And within that, we will install Apache web server on it. And then we will test it. That's what we will be doing. So this is a virtualization concept, right? So you have your physical machine to virtual machines. Now, there is if you step back and look at the industry trends, so we went from physical machines to virtual machines, and then there is another concept called containers. So containers is taking it to the next level. Here, if you really look at it, if all of my applications are Java-based applications, then why do I need a separate virtual machine? Why do I need operating system? I should be able to handle with single operating system, and then multiple, they call it containers. Containers are nothing but a lightweight machine. So you will not be wasting a lot of resources by installing a separate operating system. You don't need to do that. That's the concept of containers. So those containers, somebody has to manage those containers, meaning somebody has to scale them up, scale them down. So that is what Pivotal Cloud Foundry does it. So without you having to worry about underlying operating system, you just deal with high-level abstraction in the form of Pivotal Cloud Foundry. So Pivotal Cloud Foundry has some commands. They call it CF scale -i6. Let's say that's a simple command. So you are instructing Cloud Foundry to scale the instances to 6 instances for this particular application. You can scale down, scale up. So you're only interacting with the Pivotal Cloud Foundry, and that internally managing all the containers, all the virtual machines under the hood. It acts as something called container orchestration. Okay, so this is a Pivotal Cloud Foundry. If you do not understand, please don't worry about it. I happen to have worked on PCF, so that's why I know about it. Now, the other one is Kubernetes. So the Kubernetes is a true container. There is another, in the container world, there is a popular container vendor. It's called Docker. So these Docker containers, again, you need orchestration. Somebody has to be able to orchestrate them. How many Docker containers do I need? Scaling up, scaling down, all of that. So for that, you use Kubernetes. Kubernetes is actually Google's own container orchestrator. Okay. So how does it play with AWS? Well, AWS provides a service called Amazon Kubernetes Service. Amazon Kubernetes Service. Okay. So you can use the Kubernetes service to install Kubernetes as a without you having to worry about how to install Kubernetes. Okay, it will come, pre-installed Kubernetes with it, and you'll be able to manage the Docker containers using that. So Amazon has a couple of options for this container and container orchestration. One is called ECS, Elastic Container Service, and the other one is EKS, Elastic Kubernetes Service. And then there is a third one called Fargate. In Fargate, just, you don't have to worry about any of it, and underlying container orchestration, you can pick it up. So you can play with the EKS, Elastic Kubernetes Service, and it's pretty simple. But will I be able to cover that within this 4 or 5 weeks? I doubt it. I don't think so. At least I have not done so far. If you guys are so pumped up, then if you are pumped up, I'm pumped up. So if you want to play with it, absolutely, we can do it together. Not a big deal. In fact, I took the certification recently, and there was a question about Fargate versus EKS. EKS is actually, the EKS is vendor agnostic, Elastic Kubernetes Service, because Kubernetes is not only, Kubernetes has got nothing to do with AWS. Okay, you can take Kubernetes to Google Cloud Platform or Microsoft Azure or somewhere else. So Kubernetes is really an interesting and upcoming, it's not upcoming anymore. I think it's there for the last at least 5-6 years, probably. So it's been there and very popular. We can play with some Docker containers, and then have, we can use EKS, Elastic Kubernetes Service, as a container orchestration, meaning using Kubernetes as a container orchestration. We can try doing that towards end of the course as a fun exercise. Absolutely, I'm all about it. And I know some of you guys in this group here are very interested in that area, and I know that you guys bring a lot of energy. If you guys want to do it, I will fully support it, and I'll jump in and we'll do it. I can even show you. Okay, so, but I don't want to also confuse you guys with the lot on day one. So I want to step back here and talk about some of the fundamentals of AWS, and then we'll start provisioning our own virtual machine. With that, I want to take about 10 minutes break. Actually, 9:46, right? Let's meet at 10 o'clock. Let me pause the recording for a second, actually. No, in fact, I can stop the recording so that it can be broken. Stop.